Good morning, everyone. Good afternoon and good evening. My name is Budiman Minasny. It's a pleasure for me to welcome you to the 4 per Meal Scientific Series seminar. We are back again online, and this scientific webinar series is presented by the 4 per Meal initiative, where we discuss topics with regards to soil carbon. My name is Budiman Minasny. I'm from the University of Sydney, and I'm also a co-chair of the Scientific and Technical Committee of the 4 per Meal. So today we are very glad to have two young researchers to talk about soil security and its relation with 4 per Meal. So first, I would like to introduce our first speaker, Dr. Watini. Watini is a postdoctoral fellow at the University of Sydney, and her work is focusing on soil security, especially quantifying the the dimensions of soil security. So I'll invite Watini, and the floor is yours.
Thank you, Budiman, Professor Budiman Minasny. It's an honor for me to be able to speak on this webinar. Let me just set up quickly. So today my talk will be about aligning the 4 per 1000 or 4 per mil initiative with the soil security assessment framework. My name is Watini, and I'm a research fellow at the University of Sydney. I am also a secretariat of Aurora, the soil security think tank that was recently established. So 4 per 1000, also known as 4 per mil, is an initiative to increase soil carbon in the soil at the rate of 0.4% per year. This initiative is basically developed as a method to mitigate climate change. As you can see from the figure on the right-hand side, approximately 8.9 gigaton of carbon was emitted from fossil fuel combustions alone. This does not include an additional 0.9 gigaton of carbon due to deforestations. Although some of these carbon emissions are absorbed by vegetations and oceans, overall, there is still a positive influx of carbon emissions through the atmosphere. Hence, there is a call for a 4 per mil initiative to increase carbon content in the soil to mitigate this carbon emissions. However, storing carbon is not the only role that soil provides. Soil also provides many different roles, including providing food and biomass productions, storing and regulating water, storing and regulating nutrients, as well as providing habitats for biodiversity. And because of this, there has been many soil care concepts being developed. The first one would be soil quality, soil health, soil fertility, and soil protections. Some of these concepts probably you have heard of or been familiar with. And more recently, there has also been soil security. So hopefully you have also heard about this concept as well. So what is soil security? Soil security refers to responsible management, preservations, as well as restorations of soil to guarantee its continuance, ability to perform various functions, services, and resilience towards threats to support the life on Earth. Within soil security, we recognize that there are 5 key dimensions. The first one is capacity, which reflects the inherent ability of soil to perform certain role. This is mainly related to soil quality. The second dimension is conditions, which indicates how soil is currently performing. We can relate this more to soil health concept. There is also capital, which relates to the economical aspect, and connectivity, which relates to how people relate to the soil, as well as codifications, which relates to policies and laws to protect the soil into the future. So overall, the soil security concept covers not only the biophysical, but also the socio-economic and the governance dimensions. Within soil security itself, we also recognize that soil has many different roles. We further break it down into three main roles. We have functions, services, and threats, and under each of those roles, there are subcategories that we consider as well. So if you take a look at soil security concept in a glimpse in comparison to other concepts, you'll have something like this. Basically, soil security is a holistic concept that evaluates soil across the 5 dimensions and 3 different roles that I was mentioning before. If you were to map soil health concept onto this space, you'll probably get something like this, in which case soil health covers the conditions and the connectivity dimensions, but only on a portion of functions and services. It doesn't cover all across all different dimensions and roles. If we take into another example of soil protections, this one also only cover a portion of the whole map. So soil protection cover the conditions and codifications, a bit of functions, and a bit of threats is being covered within the concept. So to do a full assessment of soil security, you basically need to assess across the 5 dimensions and 3 different roles that encompass this 23 total activities. So in total, you'll have approximately 115 of evaluations. Now, you don't have to do all these evaluations. It would also slightly change depending on what you're after. If you're after a particular functions or particular role, you can also do it that way, or you can do a full assessment. So you don't always have to do the full assessment is what I'm trying to say. All right, so if you were to put that into a table format, you'll get something like this. Basically, we have the 5 dimensions across the 23 different activities. But for the purpose of this talk, we'll be mainly focusing on the activity of storing carbon, focusing on the biophysical aspect, capacity, and the conditions. So before we go on to the details on how to use this assessment framework, we need to acknowledge that not all the soil are the same. Soil varies spatially, and there is a need for a concept that's called reference soil, because there's no one-size-fits-all solutions. Imagine the same soil formed under a similar forming factor. It can be used for many different land uses. For example, the original land use might be for growing for forestry areas, but then you might change the land use into grazing or cropping areas. So there needs to be some sort of concept that can be applied to do a quantitative assessment overall. So for this, we develop a concept that's called pedogenon. Pedogenon is essentially a conceptual classes that aims to group similar soil that was formed under similar forming factors together. So the way we do this is we collect the soil forming factors of the soil. This will include the climate, organisms, relief, and parent material environmental covariates. We perform unsupervised classifications, which then gives us our finalized pedogenon maps of Australia. And within these pedogenon maps, we can further break it down into a phenosoil and genosoil. Phenosoil refers to a soil in which there are more human activities involved, which change the land uses. Meanwhile, genosoil is a soil in which there is least modifications from the human. So essentially, you can consider genosoil as your sequestration's target potential if you want to compare how is your current soil conditions is doing in comparison to its capacity. So over here, I'm showing you a case study done by a colleague of us in Sydney Uni here. So basically, Kantani is trying to assess the carbon change between genosoils and phenosoils. He collected the data that was readily available through Soil and Landscape Grid Australia, and then basically he grouped it into genosols and phenosols. And what he found is that if the carbon content is quite relatively low, so if you see on this my cursor here, basically the relatively changes is not that much in comparison from genosol and phenosol. But if the carbon content is high, he noticed that there's a trend of decreasing if you compare the genosols and phenosol, which is a quite interesting find, I think. So that is one example of using in one indicator to assess a particular activity, but to assess one activity in a whole, usually you would need many different indicators, also properties. So to do that, we developed something that's called Soil Security Assessment Framework. It has 4 different steps. I'll go one by one. The first step is basically assessment target. What it means is basically you identify what you want to do. So I've mentioned in the beginning that for the purpose of this talk, we're gonna mainly focus on the role or the activity of storing carbon and focusing on the capacity and condition dimensions. So then the next step will be selecting their particular indicator, relevant indicators that can be used to assess this particular activity. So for this particular exercise, we are choosing soil organic carbon, soil inorganic carbon, and mineral associated organic carbon as our indicator. Luckily, in Australia, we are blessed with many data that are available. We have this data available in digital maps recently, I think. So we basically collect all of the relevant rasters of soil organic carbon, inorganic carbon, and mineral associated organic carbon. And the next step of the framework is basically estimating a utility. What it means is that you convert the indicators into a unitless score of ranging between 0 to 1. This is particularly useful especially if you're using indicators that has different units, so you can compare it more efficiently. So over here, basically to estimate the utility of the soil function carbon storage, focusing on the capacity, we are mainly using the genosoil observations. And what we are saying is that if the genosoil of the particular pedogenons is at a particular level of a threshold, let's say for organic carbon, if it's at a threshold of around 4.8, then it'll get a capacity of 1. If it's below than that, then it will follow the curve to identify a relevant utility score for that particular indicator. So you would apply the same across all different indicators that you're using. The threshold is slightly varies because soil organic carbon mainly accumulates on the top soil. Meanwhile, soil inorganic carbon accumulates on the bottom soil. Hence, the threshold slightly different as well. So if you were to convert the observations of the rasters that you have into utility score, you will get something like this, in which case what it means is overall the capacity of soil to store carbon is relatively low because all the raster value, the color is ranging from 0.2, let's say, to 0.5 or 0.6. So in some area, you notice that there is a high capacity, such as the Tasmania, as a yellow color for total organic carbon. And then for the soil inorganic carbon, there is a higher values of storage in the Southern Australia, where the calcareous soil is. And the mineral associated organic carbon follows the pattern of the soil organic carbon. And then over here, we are doing utility estimations of conditions. To do utility estimations of the conditions, we usually compare it against the capacity. So in this case, for soil organic carbon, if the content of organic carbon in the genosoil minus the phenosol there's not much difference, then the condition is 1, which means it's healthy, it's secure or healthy. But if the carbon content of the phenosol is much lower than what the capacity is, that means the condition becomes lower. So you apply the same trend across the different indicators, and you will get a map that looks like this. What you notice is that on the capacity, it's relatively low, but over here, we've got a map in which it shows that the storage conditions is relatively high in Australia, particularly for soil organic carbon and soil inorganic carbon. So although the capacity of the soil in Australia to store carbon is relatively low, the condition is relatively good. The final step of this assessment framework is basically assessing the aggregate the assessment. So what it meant is, like, before we have all the stream maps, instead of comparing it side by side, it's difficult, and we just aggregate it into one final map to have a final utility scores. So on this map, we basically do an average of a mean across all the different indicators, and we have a map that looks like this. Basically, you'll see the same trend, higher capacity overall to store carbon in the southern Australia, some in Tasmania as well. And then you'll do the same to aggregate the assessment to store carbon for the conditions dimensions, in which case you get overall unitless score of around 0.8. So I'm just showing one example of assessing the ability of soil to perform certain role. There are many different functions that soil performs. If one person is trying to perhaps improve ability of soil to perform a particular role, there might be a chance that there is a trade-off that it might degrade the conditions of soil to perform another role. So to conclude, storing carbon is one of many different roles that soil supports. Soil security assessment framework enables the recognition that there is a diversity in the soil, and we basically acknowledge that diversity through the use of petagenome concept. And complete assessment is very extensive and most likely require many, many collaborators. And with that, I'd like to conclude my presentations and thank my colleagues and the funding to make all of this research possible. I'm going to hand over to my colleague Sandra, she's going to talk about different dimensions of soil.
Thank you, Watini. Thank you for doing the heavy lifting and explaining the soil security framework. Makes my life a bit easier. Okay, so hi everyone, I'm Sandra, and I will be taking you through some of the more socio-economic and governance dimensions that Watini touched on in the soil security framework. So I want to emphasize that these dimensions are equally as important to secure soil into the future. Without capital, or without people valuing the soil, without people seeing its importance to their lives, and without there being any policy or regulation in place to protect the soil, it's difficult to secure soil long term. So these are equally important for soil security. So taking you through each one in a bit more detail, capital refers to the economic or monetary value of soil. And I would say it's arguably the least investigated dimension, largely due to its complexity. So there are various forms of capital. There's natural capital, the value of its services that it provides, difficult to estimate. Production capital, probably the most tangible form. It's the value of what it produces. But there's also things like replacement costs, cost to replace nutrients, loss or carbon, as well as transition costs. What is the price to change land use or to restore the soil? And we saw this paper, I think my colleague for this slide, there is this paper on monetization of soil. And I think the authors put it very well here. They say that assigning an economic value to soil may seem unconventional, but it could effectively highlight the importance of this finite and diminishing resource. Giving soil a tangible value could raise public awareness, improving management and strengthen conversation. So I'm not an environmental economist in any way. However, the idea with capital is that when we value the soil, we can see that it is worth protecting and we can avoid neglect. In terms of the relationship of soil security and soil carbon, we have this concept of soil security. And then we have soil carbon, which is a very useful and probably the most important indicator of soil security, because through it we can measure many different functions, services, and threats. And soil carbon is one of the only soil properties that is really valued. For example, with soil carbon credits, it creates initiative to build carbon in the soil, which in turn has many benefits to improve soil functions and so on. But we shouldn't only value soil carbon, we should also value the functions, services, and resilience towards threats that soil carbon provides. Using the soil security assessment framework, one of our colleagues here did a study to quantify different aspects of soil capital in Australia. They did this by looking at one function, one service, and one threat and combined it into a monetary metric. And soil carbon here played an integral role. They integrated the price of carbon to make the assessment. And they found that increasing 1 millimeter increase in available water capacity results in an increment of 293 Australian dollars per hectare in farmland price in Australia. So if we increase carbon, we can also increase the available water capacity, which also increases the value. So there's a lot of value in terms of soil and also carbon. The next dimension is connectivity. Connectivity is the social aspect of soil security. It's all about the relationship between people and the soil that influences action. And this is critical because it's a big driver of change. When people know about the soil, they learn about its importance and the relevance to their lives. So it's likely to lead to more sustainable choices and actions. And I think this is really epitomized by the quote, "Those who know learn to care, and those who care lobby." It seems simple, perhaps even obvious, but there is a large disconnect between people and soil, particularly within cities where we can feel quite separated from the natural world that sustains us. And rebuilding this connection starts with public awareness, soil literacy, and education. And I wanted to highlight that this is one of the many reasons why Soil Day that's coming up on December 5th is so important. It provides a global moment not to only appreciate or celebrate soil as a foundation of life, but it also engages the broader public and shares knowledge to the soil that supports us. An example of having strong connectivity can be through cultural ties. Indigenous Australians have always had a deep cultural and spiritual connection to the soil. They have a sophisticated understanding of the land, seasons, and ecosystems, which they manage sustainably. And this understanding provides valuable lessons for us today in the changing climate. And there is also culture and carbon. So Indigenous knowledge encompasses a holistic understanding of ecosystems, biodiversity, and sustainable land management practices. And carbon is also shown to help heal country. In Australia, Indigenous cultural burning of areas was found to have a more pronounced effect on increasing organic matter content. And it helps to also promote new growth and maintain the soil condition. And there's also many other benefits, such as restoring soil functions and providing more water in a very dry climate in Australia, and more nutrients for the native plants which need it. One of our colleagues here at the University of Sydney has also been looking at quantifying connectivity. They put out a self-evaluation tool where 315 land managers nationwide participated in using, and it asked a number of questions about their knowledge, their attitude, and actions towards certain functions, services, and threats to soil. And their responses were then connected to spatial data of soil across Australia. So in this particular example of the threat to soil decarbonisation, they found that land managers generally have good knowledge about soil carbon. However, it's not always translated into their attitude and action. And this highlights a no-do gap. Investigations like this can reveal what we need to do to promote or incentivize soil security depending on the region. And future studies are also needed to see which dimensions of soil security should be strengthened so that we can ensure that this knowledge is translated to attitude and action. And the last dimension is codification, which is about soil governance. This involves policies, regulations, legal instruments to protect the soil. It's not only about what policies exist, but also how the impact of these policies. Around the world, there are not many countries that have legally binding policies on the soil, and often soil protection is embedded within other policies. For example, policy on the environment or preventing contamination. And some work that we've been doing on assessing codification is using the soil security assessment framework to help us identify any gaps so that we can better protect the soil. This current project, we were looking at various types of legal documents across Australian states, and we found that many documents dealt with soil security in some form, in some way, but we could also already see that some do a bit more than others. And if we break down these documents into which roles they address, when we look closer, we can see that most documents are to do with decarbonization, food and nutrition securing, and store, purify, and regulating water. But on the other end, there's less to do with store of carbon. So many of these documents are about preventing decarbonization, but not about building carbon. And so the soil security assessment framework is useful to identify these gaps. Looking across the world, when we look at the number of related legal instruments across time, we can see that there is a slow adoption of some form of soil protection, laws per country increasing. However, today soil governance is currently voluntary, and there is no global policy or law that exists dedicated to soil. And this is why we established Aurora, the world's first think tank that is dedicated to soil and securing it into the future. And the name Aurora comes from an ancient Greek word meaning arable or fertile land, which is, I think, quite fitting. Their mission is to assess these critical gaps made by the absence of soil at the global level and provide evidence-based policy input. And I'd like to highlight here that the expert panel of the think tank that has been put together are not only soil scientists, but they're also economists and lawyers because of this multidisciplinary nature of soil security. And as mentioned, part of the mission is to provide evidence-based policy input. So they have recently developed and published soil policy principles that can be useful in developing national and global policy. And these policy principles are based on the dimensions of soil security, but they are also soil-centric. And soil-centric means that they focus on soil rather than conflating it with land or land use. So just taking a look at a couple of these principles, the first one is soil policy should recognize the intrinsic diversity of soil. And this goes back to Watini's presentation at the start, recognizing that one size does not fit all, and that different soil have different capacity to do a function, and we must manage the soil within that capacity so that we don't degrade the soil. Another principle is soil policy should be evidence and knowledge based and evidence and knowledge enhancing. And this perhaps reflects more on the connectivity dimension, ensuring that our decisions are informed and they build our knowledge. And you can read more on these policy principles in the paper. Based on these principles, Aurora supported the motion of the IUCN motion of 007, the Soil Security Law, which was passed at the World Conservation Congress last month, which is very exciting. This motion was co-proposed and championed by Dr. Irene Hauser, who's also a member of the expert panel of Aurora, as well as Professor Anchini Vitanaj, and she's from the Pace University. Essentially, the motion calls for the development of a global legal instrument to protect soil by recognizing soil as the foundation of our global as the foundation of food security, biodiversity, climate resilience, and environmental justice. And this motion has been grounded in the Soil Security Assessment Framework, which helped to provide a structure for policy and scientific research and legal inquiry. So the main takeaways are that to secure soil, we also need these socio-economic and legislative dimensions. Soil carbon is a very important indicator to be able to measure aspects of soil security, and the soil security concept and 4 per mil work hand in hand to secure soil. Before I finish, I'd like to let everyone know that we are also putting out a series of webinars in around March next year so that you can learn a bit more in depth if you are interested to use this framework in your area. And if you'd like to also be updated in similar events or want to be active in joining the discussion, you can become a member of Aurora as a friend of soil security. And we invite you, we will be also sharing some content on World Soil Day. And I'd just like to say thank you to everyone in the team and to the ARC for funding this project. Thank you very much.
Okay, thank you, Watini. Thank you, Sandra, for the comprehensive evaluation, comprehensive introduction on the soil security. So we learn from the biophysical dimension until the socio-economic as a whole package of soil security. So next, I would like to invite our panelists, our discussant, Professor Beverly Henry. So Beverly is a professor at Queensland's University of Technology, and she's also a member of the Scientific and Technical Committee of the 4 per Mil. Over to you, Beverly.
Thank you, Budiman. And yes, I encourage questions in the chat, please. But I'd just like to start off the discussion today. And firstly, to thank both Watini and Sandra for brilliant presentations. My head is spinning from all the information that you've given us. I have so many questions I'd like to ask, but it was just wonderful to see how comprehensive this soil security framework is. And it brings together a lot of the improvements in monitoring soil and in understanding soil and how to manage it well, that have, I think, dogged both researchers and policy people for a very long time. And, you know, I'm still trying to get my head around the five dimensions and the 23 functions. And just to start the conversation going, I mean, it's a brilliant tool for both communicating and for improving the value of policy and other initiatives like 4 per 1,000. But to me, it seems that the real value comes in how comprehensive it is. And while individual farmers can't actually probably get their head around either what to measure, I'd just like to get your comments on how the assessment would work at the farm scale, how the guidance is given to land managers to ensure that this great framework is actually able to be applied and ultimately lead to improvements in soil and soil sustainability. So I guess I'd ask Dr. Watini first, but Sandra, please come in as well if you'd like to comment.
Right. The question is basically how does the farmer utilize this assessment tool in a sense?
Yes.
Is that correct?
Well, right. How the information from the tool would be given to the farmer to guide his management, his or her management.
Right. Thank you for the question. I think the answer would be it depends. So on what the stakeholders, farmers or land managers want to use the soil for. As was mentioned in the presentations a bit earlier, we developed the concept. If you want to do, if people wants to do the full assessment, they can basically do it across all the dimensions and all different activities or roles. But for a particular farmer, maybe they might find a particular role might be more suitable for them, so they can focus on that and adopt relevant role that they want to assess, and then use relevant indicators to assess which dimensions they want to see what's happening in a sense.
Thank you. Sandra, would you like to comment?
I think she covered it well. Maybe the only thing I could add is perhaps looking at the other roles in terms of threats to soil. It could be useful in detecting any early warning signs, which threat they may have to focus on, and maybe it's also useful in creating priorities for management. Yeah, that's all I'd like to add.
Okay, so so in a way, the soil security framework would provide a pathway to practical activities to ultimately enhance soil security, but that may come in steps. So they may initially look at just some aspects of it. Okay, thank you. Thank you. Sandra, I'd like to just understand a little bit more about the value of the socioeconomic aspects and the communication and the connectivity. Because as scientists, and as you rightly pointed out in your figure, there's a long history of investment in research to understand aspects of soil, and particularly in productivity, the biophysical aspects. And even in 4 per thousand, when we look at one component, the soil carbon component, we in the Scientific and Technical Committee have really grappled with how to better use socio-economic indicators and to understand what drives the adoption of better practice. And so how can we bring the evolving soil science knowledge together into the framework that also allows for that assessment on a social and an economic basis, and allows us to feed that information into policy that gives it more value? Because for the 4 per thousand initiative, for food security and climate change, we would love to be able to bring that information together. So can you say how we can work together to make that happen? How would you suggest that engagement occur?
That's a great question and quite a hard question.
Sorry.
No. It's good to think about. I mentioned in my presentation that soil security is inherently interdisciplinary, and that's why we have these different dimensions. How to engage more effectively with each other? And Watini, please jump in if you have any ideas. I guess it's just building that connectivity with the soil, realizing that soil is not just used for agriculture, but it's relevant to everyone. Particularly in our urban soils, which we enjoy, and we have, which sustains our lives. Creating networks translating this science to be used in policy. It's quite difficult.
Thank you. Watini, did you want to comment, or I can follow on with another question if you'd rather?
I think it would depends on who you're trying to communicate to. So how you reach to them would be slightly different in a sense. But I agree with Sandra that probably when we reach out to these various stakeholders, we'll probably fall back onto the different dimensions. If we're reaching out to, let's say, the economists, we'll probably bring out the capital dimensions that's more relevant to them to be able to communicate something that's more relevant to the stakeholders, so they are more engaged and would like to adopt the concept in a sense.
Yeah, I mean, that makes sense. I mean, ultimately, we want to ensure that I guess the unique capacities and vulnerabilities of different soil types, that they're all respected. And that's part of what I got out of your talk today. And that's a difficult thing too, because there's such a range of national and global agendas at the same time that are driving action for soil. So, agendas such as carbon markets, food security goals, and pressures and land use policies, they tend to favour a sort of one size fits all. So, balancing that against the diversity and the unique capacity of different soils is something that I think is really a strength in what you're doing, that you can contribute through the framework in understanding how we can manage that balance. So I guess, are there mechanisms that can translate and help communicate the idea of soil capacity, for instance, into real world policies when there are so many different drivers? That might be more a comment than a question.
Well, are there mechanisms? We don't know the direct path. We are just, I think, at the moment, just building the bridges to get there. So we did develop the principles. For example, we did write something to try to achieve global convention on soil, and we try to develop a template for national soil strategy. So we're building all these building blocks as a bridge to get to where we want to be at the end of the day, to secure soil into the future, basically.
Yeah. The soil security law that you've achieved so already with IUCN is a great achievement. I'll come in with I have plenty of questions, but we might just go to the questions on the chat, if that's okay, or the comments. Let's see. There's a lot of enthusiasm in the chat. I don't know whether you can see it. There are several participants that would like to trial the strategy, so the framework. And even the suggestion that we make soil security part of the school curriculum. And I think that's ambitious, but I think it's an excellent idea because, as you implied, soil is sometimes a bit hidden in its value, and we see it as something that provides a service, but we don't actually value the soil service itself. So are there any questions that anyone would like to add? I'm not sure whether you can ask them in person. I think you have to add them to the chat.
Well, Beverly, I do see that in the Q&A there are a few questions there.
Right.
Separate tab from the chat.
Yes, okay. You're right. So yeah, let's look at some of these questions. Thank you, Sandra. How capable are Australian soils to capture 4 per thousand annually, and for how long? It seems would be mainly the mineral associated organic matter, that is the total gap in carbon. And the questioner didn't leave their name, but it's a very good question and one that I think would be of wide interest. I just comment there that Australia is very fortunate in having such a lot of data, a lot of soil data and a lot of digital mapping of soils, and that may not be available to all countries that are participating, but it is very valuable. Watini, would you like to make a comment?
Yes, I can try to make a comment, but feel free to jump in and add any other comments if you have any, Sandra. So how capable is Australia to capture this? I think it depends on the region as well. And in the maps, we show that in general, Australia has low capacity of soil to store carbon. But like the condition is relatively well. In some places, you probably can increase soil carbon, but it will depend on the area where it's located and how the soil is managed as well. So I haven't done any assessment in particular to see how it works, but that's just my thought. Yes, in some area you can increase the carbon, but it probably needs ongoing work with the monitoring to validate this as well.
Thank you. I mean, as I mentioned, Australia does have very good soil data. And one of the questions Tao asked, can this soil security framework be applicable across diverse climates, or is it yet to be calibrated for other regions other than Australia? And I think you've partly answered that, but yeah.
I can comment a bit on that as well. I think there's another colleague that is working on basically assessing the same indicator of soil organic carbon across different climates. And if you're just comparing just the genosol versus phenosols, you can't really see much of a difference. So he was proposing, because the area is quite large and he does not, in that study, he hasn't acknowledged that the soil diversity, he hasn't taken into account the diversity of soil. But one of the case study by another colleague in which he focused on a small study area, he found out that, well, basically it could potentially change depending on the climates and the land use on top together.
Okay.
Thank you. I can also add a few comments. Yes, definitely can be applicable across diverse climates. And we do recognize that sometimes not all soil properties that you'd like to use as indicators are available. So sometimes you have to be quite pragmatic or work with what you have. And so you can use those as indicators, those properties as indicators, given that you have a utility that reflects the relationship between that soil property and the role or function being assessed. So then it can be applied in different areas.
Okay, thank you. That seems very interesting, Sandra. Thank you. There's a question here from Julio, which is, yeah, it's very interesting. I don't know whether you're able to answer, but he says you said there isn't a global law for soil, but are you suggesting we should have a global convention for soil, like there is one for climate change and for biodiversity?
Very subtle. Yes, there isn't a global law for soil. And in terms of a global convention on soil security, that is the big ambition of Aurora. Yes, we have conventions on climate change, biodiversity, land degradation that address parts of soil within each of them. However, they're not centralized, or they don't focus on soil itself, where we can drive more change in our action. So that is the ambition for Aurora, to have a global convention on soil security. However, this soil security law motion 007 that was passed as a resolution, that is just opening the discussion to all the nations, all the groups, to discuss what type or what this global instrument will look like. It's just opening the discussion. Great question.
It is. But I mean, that's where the strength of the framework, the soil security framework, would really come into its own in supporting a general law. But the first step is probably, do you think the first step is probably increasing the awareness and understanding and communicating why you need a law? And that's, I think, something we all have to work on. Okay,
Very
thank
well
you.
said.
Thanks.
And the last question is one that I'm not sure how to answer either. From India, Sadashiv wants to know how we can all work together collaboratively, and particularly for India. So do you have the capacity at this stage to engage with research groups in other countries?
I think it can be open for discussions. They can clearly they can reach us, and then we can discuss what we can do as a collaboration study for the soil security assessment framework, because we did some collaborations work with other universities as well. So definitely open for collaborations.
Thank you. And I did note that you pointed out that you are happy to collaborate with 4 per 1,000 because of those common goals as well. And it's through those other organisations too that the soil security framework, it cuts across all of them. So there are probably many opportunities to work there. Budiman, did you want to add anything at this point?
No, I think we have a great discussion. I think it's almost it's almost time that we have spent this wonderful time listening to the presentation and also a great discussion. I think we covered a lot of things from the capacity condition down to the international law. I think it's quite comprehensive. I think it takes a while to digest all of this, and I'm still going to. I think Do you have any other comment, Beverly, that you want to?
No, I would just reiterate what you just said, that the presentations are a wonderful opportunity. To be honest, I have read a couple of your papers on soil security, but I didn't really understand how it worked until you presented it. So that that was a great opportunity for us. And so thank you very much for your time and for all the preparation that you put into it.
Okay, thanks Watini, thanks Sandra for the wonderful presentations. I think we have to end now. It's almost 1 hour. So on behalf of the 4 per mil, we would like to thank the presenters for their contribution. And this will be the last webinar for this year. And we'll start again for the webinar series of the 4 per mil starting in February, on the 12th of February. Please mark on your diary, so where we will discuss about enhanced rock weathering. So this is also a controversial and an important topic that's related to soil carbon. So have a good break and see you next year. Thanks, everyone.